Hello SL and HL. I've had a request to do a couple of more difficult type arithmetic and geometric sequence questions. I just pulled this one up. This is an exam question. It is from a paper 2. Let me just write that down. So it is a paper 2 type question. That means you can use your calculator, and it is also a standard level question, okay? But that is not to mean that it may not, it could not appear on the HL paper as well, okay? Because remember, there is quite a lot of overlap. So it does look quite nasty, but let's have a look at it and see how we get on, okay? So I'm actually just going to stop. I want you to pause your video and have a go at it. It's a 12-mark question. Give yourself about 15-20 minutes, see how you get on, and then hit play when you're ready, okay? So we've got an arithmetic sequence. We've got U1 is 1.3, U2 is 1.4. We're told that the ukth term is 31.2. So if I just write down, this is my first term, this is my second term, this is my kth term, or nth term as we're sometimes used to calling it. And you have to remember, for your sequences, you're given the formulas. So the formula for the nth term is u1 plus n minus 1 times d. And we're also told the formula for the sum of the first n terms, which is n over 2, 2u1 plus n minus 1 d. Or you could have n over 2 first term plus last term. Okay, and those are given to you. So the first thing we need to work out is, I haven't even read what the question is, but I am wanting to just have a look at this. What is D? D is the common difference. Okay, what do I add on? I'm adding on 0.1 each time. Okay, so I've got my first term, I've got the common difference. We're told, consider the terms un of this sequence such that n is less than or equal to k. Let f be the sum of the terms for which n is not a multiple of 3. Okay, so if it's not a multiple of 3, then it can't be 3, 6, 9. Those are all multiples of 3. So f is the sum of the terms which can't be one of these numbers, okay, a multiple of 3. Okay, so let me just check what the first question. Okay, so for some reason for this question, there is no part A, just go straight into part B. Find the exact value of S of K. So I can use, essentially I'm going from the first term up to the kth term. This is my first term, this is my last term, okay? So I need to work out how many terms have I actually got here, okay? If I'm going to use this formula. What term is this? Okay, and I'm going to use this formula. Okay, so let's put in everything we know. The kth term is 31.2. The first term is 1.3. And d is 0.1. I'm going to subtract 1.3 from both sides. I'm going to solve this essentially for k. I can use my calculator. Okay, so I've got 31.2. I'm going to subtract 1.3. 29.9 is equal to k minus 1 times 0.1. I'm going to divide both sides by 0.1. I get 299. That's equal to k minus 1, and then add 1 to both sides, and I get k is 300. So this is the 300th term, okay? First term, second term, 300th. So I'm going to sum up, back over. I want to use this formula now. 300 over 2, first term, 1.3, and I'm going to add on the last term, 31.2. This is the sum of the first 300 terms, and that gives me, I can put this in my calculator, come on over here, 150 multiplied by 1.3 plus 31.2, 4875. Okay, make sure, did you get it? Okay. All right, let's have a look at the next part then. So just change color, and let's go black. Okay, so show that f is equal to 3240. Okay, now we said f is the sum of the terms for which n is not a multiple of 3. So let's look at our full sequence. Let's ignore f for a second. We've got u1, u2, u3, u4, u5, and that goes all the way up to u300. Okay. Now we're told that f is the sum of the terms for which n is not a multiple of 3. So n in this case is 1, that's not a multiple of 3. N in this case is 2, that's not a multiple of 3. N is 3 in this case, that is a multiple of 3. So don't want that one. U4, I want U5, and this is going to go all the way up to, well, U300 is a multiple of 3. 299 is not. That is what f is, okay? So how am I going to work out how am I going to show that this sequence is equal to 3240? Well, what I could do is, I know that the total of all of this sequence, I know what this is. I have worked this out. I've worked out what the sum of all of that is. Let me just write it down. I know that u1 plus u2 plus u3 all the way up to plus u300 is equal to 4875. That is what I've worked out from the first part of the question. I want to work out what this is. So what I could do is, well, if I can figure out what u3 plus u6 plus u9, if I work out what the sum of the answers with the multiples of 3, if I can work out what this is, then all I need to do is subtract those two answers, and that will give me what f is, okay? That will give me the sum of the terms for which n is not a multiple of 3. So how am I going to work out what u3 plus u6 plus u9 all the way up to u300 is? Okay, well, first off, how many terms have I got here? Well, let's change color. This is my first, second, third. Hopefully it should be easy to see. 3 divided by 3 is 1. 6 divided by 3 is 2. 9 divided by 3 is 3. 300 divided by 3 is, this must be my 100th term. So if I want the sum of these 100 terms, it's going to be 100 divided by 2. I'm going to use this formula again. The first number is U3. Now U3 is going to be 1.5. The last term is 31.2. I can work that out on my calculator. 50 times 1635. Okay, so the sum of all these, the multiples of 3, 1, 6, 3, 5. Okay, so this is all of the terms, is 4875. This is just the terms, which are multiples of 3, 1635. If I want everything that is not a multiple of 3, okay, then I just subtract these. So f is going to be equal to 4875. Take away 1635. Take away the previous answer, 3240, which is what we are after. Okay, that's quite tricky, and just in terms of how it's worded, but hopefully it kind of makes sense. Okay, I've got the sum of the first 300 terms. I've also got the sum of just the ones which are multiples of 3. Subtract them, that gives me everything that is not a multiple of 3. Okay, last question. Oops. Okay, so part D, we are now given an infinite geometric sequence. Okay, first term is a, the next term is a over root 2, the next term is a over 2, and so on, and it goes, we're told that a is a positive integer. And so looking at our geometric sequences, the formula for the sum of an infinite geometric sequence is a divided by 1 minus r. R is the common ratio. So what is the common ratio here? What do I multiply a by to get this term? What do I multiply this term by to get a over 2? Well, 1 over root 2. 1 over root 2. So r is 1 over root 2. So I want to find the largest value of a such that the sum of the infinite geometric sequence is less than f. And I've worked out f to be 3240. Okay, that is what f is. So let's put down the formula. I've got a over 1 minus 1 over root 2 is less than 3240. I just want to move my pH up a little. So let's solve this for a. So what I'm going to do is multiply both sides by 1 minus 1 over root 2. Multiply this by 1 minus 1 over root 2. So when I do that, I get a on this side and on the other side. So let's put it in. 1 minus, I'm going to use brackets, 1 over root 2. So 1 minus 1 over root 2, let's just work out what that is. Okay, that's fine, multiplied by 3240, and I get 948.97. 948.97. Okay, and we're multiplying both sides. This is actually a positive number, so it doesn't affect my inequality sign. So A has to be less than 948.97. So A is going to be equal to 948. If you have any questions about this, please ask. Hopefully that makes sense, that last one. If A is greater than this, if A is greater than 948.97, that means that my sum to infinity is going to be larger than 3240. Okay, so that's why it is. And we want less than this, so it has to be 948. Okay, that's the largest whole number. Part B is probably showing that f is 3240 is the hardest part, probably. Even if you don't get this, you can still answer part D, okay, because it tells you what f is. So you still, hopefully if you don't get part C, you can still pick up most of the marks. All right, let's leave that one there. Have a look at it. Give me any questions if you need it, and I will have a look at another one shortly.